is similar to a linear equation but it uses an inequality symbol. Okay, so they're basically the same except it uses an inequality symbol. The solution to a linear inequality is all of the ordered pairs that make the inequality true. Okay, so there's more than one answer to these inequalities, okay? So the way that we're going to talk about it is in the graphing aspect, and instead of writing every single ordered pair that works, because there's an infinite amount of ordered pairs that will work, we're just going to shade the region that applies. Okay, but let's look at an example. Our example says to determine which ordered pair or pairs are the solutions to the linear inequality below. If I look at this ordered pair, 2, 5, what does 2 represent? 2 is x, 5 is y. So you're going to plug 2, 5 in for x and y. So 2 times 2 minus 3 times 5 is less than 15. And you just work it out. What's 2 times 2? 4. What's negative 3 times 5? Negative 15. What is 4 minus 15? Is negative 11 less than 15? Yes. It does not say 45. Yes was the answer. It says less than 15. Okay? That's it. And if it's true, it's yes. If the answer is false, then it's no. So let's look at another example real quick. Negative 1, negative 7. You plug negative 1 in 4. Negative 7 in 4. Why? So 2 times negative 1 minus 3 times negative 7 is less than 15. 2 times negative 7 is, 2 times negative 1 is? Negative 2. Negative 3 times negative 7 is? Positive or negative? Positive. So negative 2 plus 21, what is that? 19. Is 19 less than 15? So your answer is no. Okay, so I'm going to skip the next two and let you do those on their own. So I'm going to go to the graphing the linear equality. Graphing linear inequalities is just another way to show all of the ordered pairs that are the solutions. So here's the steps to graph. First thing you have to do is put the linear inequality in slope-intercept form. What is slope-intercept form? Y equals mx plus b. It's the only formula y'all basically remember. Y equals mx plus b. Be sure to remember, when you multiply or divide by a negative number, you do what? We've already discussed this earlier. Yes. Remember, when you multiply or divide an inequality by a negative number, you flip the sign every time. You use a solid line for inequalities that use these two symbols. So if it has a line underneath the inequality or equal to part of the inequality, it's solid. You use a dotted line for the symbols that don't have the line underneath. Step 3 is to shade above if you contain these two symbols. So that's the greater than symbol. And you shade below for these symbols. Alright, so let's look at an example, okay? And if you don't remember step 3, I'm going to show you another way that you can do this if you don't ever remember step 3, because I don't remember step 3 ever, so I found a different way. So step 1 is to make sure you put it in slope-intercept form. How do I put this equation in slope-intercept form? Subtract 2x. So I'm left with negative 3y is less than. Can I combine those? Do I get 13? No. Do not combine those. They're not like terms. So I got negative 2x plus 15. Was I supposed to flip the sign? No. Because I just subtracted, so you don't flip the sign. It's only multiplication or division. What do I do next? By? 3y. Negative 3y. Not y. Just negative 3. So divide both sides by negative 3. Now do I flip the sign? No. So y is greater than negative divided by negative is a positive. Can 2 over 3 reduce? No. Nope, so it just stays as positive 2 over 3x. 15 divided by negative 3 is negative 5. Okay. From here, you just graph it like you know how to graph it. What's your y-intercept? We did, and I flipped it. Okay. So, negative 5. So I'm going to put a point at negative 5. What's my slope? So I do what? Up 2, right 3. Okay. Look at step 2. Is it solid or dotted? It's dotted. So you are going to connect your points with dashes. Please make sure when you are doing a dashed line, it is easily recognizable. If you put your two dashes close together, it's going to be hard to tell the difference between it and a solid line. Make it noticeable. Okay? According to step 3, I should do what? Shade above or below?
Above.
Above. So I'm supposed to shade this area. Okay? If you don't remember the step, this is what I do. Okay? What is the easiest order pair you can think of? There's an easier one than that. 0, 0. That's the easiest order pair you can ever think of. 0, 0. Plug 0, 0 in. 0 for y, 0 for x. And solve. What's 2 over 3 times 0? Minus 5. Is 0 greater than negative 5? If the answer is true, you shade that region. If it was false, you shade the other region. Okay, that's another way you can do this, by just picking an ordered pair and plugging in. Your ordered pair cannot fall on the line. If 0, 0 is part of your line, you have to pick a different ordered pair. Okay? I'm going to do another example. I want to look at number 8. X equals 7, or x is greater than 7. Okay? Is that a vertical or horizontal line? Not horizontal. Vertical. So you're going to put a point at 7 on the x-axis. Is it solid or dotted? Is it a solid line or a dotted line? It's dotted. Okay? According to my rule, am I supposed to shade above or below? Supposed to be above. But do I have an above or below? So the easiest way to do this one is just pick an ordered pair. What ordered pair do you want to pick? 0, 0. Is 0 greater than 7? No. So do I shade this area? I shade the other one, right? So that's my answer. Are there any questions over how to do these? Good. That means if this is easy, hopefully tomorrow won't be that much harder.
Why do you have to do the easy one for this?
Alright, so try to do the rest on your own.